Okay, let's solve this problem. We want to check whether, if given two trees, they are the same tree. Okay, so whether they are identical in structure and have the same values. Here's one example of an identical tree, an identical set of trees, and this one identical because of the structure and value disparity. This one is not the same. These are different. These are different. Okay. So with tree problems, if you've watched some of the previous videos, you know that there are typically two main ways of solving the problem. The first way is via recursion, and the second way is an iterative approach. So let's perhaps begin with the recursion approach. Okay, so looking at this tree, right? So you're given P, given Q. So you wanna compare them, right? And with recursion problems, it's generally just easier to have a helper method because it allows you to be more flexible with the parameters, and yeah, I think that is the that is the main reason you want to have a helper and keep things a bit nicer as well. Okay, doesn't hurt. Okay, so let's pass in the tree nodes. Okay, P and Q. Okay, the first thing I want to check is whether we have a value to compare or not. Return. Okay, so if we don't have a value for both of the values of the nodes, I want to check. Right, I want to check whether either node has a value. Right. So if either node has a value, then it means we want to return false, because it would be a scenario of this, right? So both, we're not hitting a case where both nodes have values, right? But then we're hitting a case where, for example, P has a value here, but Q doesn't have a value here, so we return false. Okay, but if both of them don't have a value, like when we reach 2, right, here no value, here no value, then we can return true. Okay, if we do have a node object, then we want to compare the values. So make sure that the P val equals to Q val, otherwise we want to return false. Okay, in addition to this, I also want to check the left. So P dot left and the right. P dot right. And just want to make sure that both of these are true as well. Okay, let's give this one a run. Submission. Okay, seems alright. We did our submission, it is accepted. So now let's try the iterative approach. Okay, so let's begin. Okay, we can create a queue. Okay, I'm just gonna borrow the same idea as when we did the the recursion approach. So the idea is pretty much the same here, but we're doing it iteratively basically. Okay. Okay. So while the queue is an empty, you want to pop it. Okay, and I want to check that both has a value. Otherwise, we also check for if either node has a value. If either node has a value, we return false, and now we validate the value of the left and the right node. Okay, and then we want to append the left and the right node's respective child. And we just continue running the loop until the queue is empty, after which we can return true. Let's give this a try. Left. Okay, can't find left. Oh, it's a dot, no, comma. Okay. Okay, something seems to be wrong here. So let's give this a look. False. Right, left and left. Right and right. Okay. No, okay. So I'm going to continue here, not just skip it. I think this should be it. No. Worth a shot. Okay, let's check it out. Okay. Okay, so we have P and Q. Oh, it's an empty. Okay, that was it. And yeah, I would say, if you do an interview, please get enough sleep. Please. Yeah, and live in a place where people don't distract you from, waking up super early all the time, so you have full energy to conquer these problems. Okay, yeah, that's it. I hope you've enjoyed the video.